read the question first. Okay, that is a 220 volt and 100 watt bulb is connected to a 120 volt source. Calculate the power consumed. Now, if you know the term of rating, what was that rating? Rating was that this bulb will be giving you the electricity, or you could say it will be giving you a energy of 100 joules per second. It will be giving you energy of 100 joules per second. And what is that? That's power actually. So it will be giving you 100 joules per second, but only in a condition, and that condition is that when you have connected it with 220 volt, right? This bulb will give you 100 joules of energy per second only if you have connected in 220 volts. What if you have not connected it with 220 volts, and instead of that you have connected with 110 volt? In this case, what will happen? That we have to understand. So you see that the bulb is not changing, though the potential is changing. And if the potential is changing, the power is also going to change. Right now we will understand. But one thing which is same in this bulb is that its resistance is not going to change. The resistance of this bulb is not going to change. Why it is not changing? Because there is a same bulb. We are not changing the material of the bulb. And if you are not changing the material of the bulb is going to stay same, or the resistance of the bulb is going to stay same. Okay. Now you will say that the resistance value is not given, but so what? We will just consider two scenario in this case, or in this question. Let's understand the case 1. The case 1 is when the rating is this, or we could say the case 1 is when the potential difference which is applied is 220 volt. Let's consider that case 1 is when you are giving a bulb 220 volt, and you know at that time the power it will be giving you will be 100 watt. Let's use the formula over here, that is P is equals to V square by R. This is the one equation. Okay, let's talk about the new potential. What will be let's talk about the new power, or calculate the power. Yeah, so let's talk about the new potential and the new power. What will be the new power and the new potential, or you could say the new let's write potential only. So how will we know that what is the new potential? We will just use the same formula, but instead of writing V square as 220 volt, we will write 110 volt, right? So, and in this case, when there is a new potential, at this case, what will be happening? The power you are giving is, we need to find that power, and the potential with which you have connected is 110 volt. Okay, this is the scenario. Now in this case, let's see that, do you know that what is the resistance? Can you find out the resistance from this formula? Yes, we can. How? We know the power is 100 watt, and if the power is 100 watt, at that time what will be the potential? The potential will be 220, or you could say when the potential is 220 volt, at that time the power will be 100, and we just need to find the resistance by doing the calculation. That will be R is equals to 220 multiplied by 220 upon 100, which will be basically 22 multiplied by 22, and that will be the value for resistance. I'm writing 22 multiplied by 22 only once over here. Instead of solving it further, I'm just using this value for the resistance. Let's write ohm over here. Okay, now what I'm going to do, now I have to find the value for the new power. At that situation, my potential is 110. The new potential is 110 volt. Let's put this potential in the case of power. So we know power is equals to V square upon R. In this case, instead of writing 220, I will be writing 110 multiplied by 110. And what will be the value for resistance? See, resistance value was same in this case as well as in this case. Why? Because the bulb is not changing. So I can write over here 22 multiplied by 22. And what about the power? Power is something we need to find out. So if you will see, it is very easy that it is 11 on the top in the numerator and 22 in the denominator. So it is like 11 twos are, so it will be 4 in the denominator, and there will be 100 on the numerator side. So the solve will be 25 watt. This will be your answer. So let me just repeat up it again. You just quick listen to it. What is happening? That we had a bulb for which the rating was this. This was the rating. And now this has been connected to 110 volt instead of 220 volt. In that case, we know that it will be giving us a lesser power than it should. Why? Because it has been connected with a lower potential. So now the potential was given to us, the power was given to us, the change in the potential, everything was given to us. So we just thought about this thing, that the resistance is not going to change of the bulb. And if the resistance is not changing of the bulb, then in both the cases it's same. So from the first case we can find the resistance and then put into the second case, and we will be able to find the power. And that's how we did this question.